All right, so we're gonna go over some more review problems, and these problems are mainly gonna deal with using the chain rule. So let's go through them. So here we first have y is equal to 7x plus 3 to the fourth power. So you see here, the outside function is the fourth power function, like the power function. It's not very good for, sorry about that. And the inside function is a 7x plus 3. So then y prime will be equal to the derivative of the outside function, which is 4 times 7x plus 3 to the third power. We keep the inside the same. We just basically use the power rule to lower that 4 to the 3. And then we multiply this by the derivative of the inside, or the derivative of 7x plus 3, which is just 7. And this just simplifies to 28 times 7x plus 3 to the third power. Right, 54. Again, we have a outside function, which is the power function or the third power function. So to find y prime, we'll get first the derivative of the outside. Whoa, it looks like I smudged my pen there. The derivative of the outside, which is 3 times x squared minus 6, all to the second power. And then we multiply it by the derivative of the inside, or the derivative of x squared minus 6, which is going to be 2x. And then this simplifies to 6x times x squared minus 6 second power. Okay, 55, we have y is equal to x squared. Y is equal to 1 over x squared plus 4. And I prefer to actually write this as x squared plus 4 to the negative 1 power. Otherwise, we have to use the quotient rule, which I don't really like to use the quotient rule for whatever reason. I just don't like it. I try to avoid it. And then this just becomes another chain rule with the outside power function, which is the negative 1 exponent. So y prime will then be using the derivative of the outside function, which would be negative 1 times x squared plus 4. Take away 1 from the exponent, so negative 2. Multiplied by the derivative of the inside, or the derivative of x squared plus 4, which is going to be just 2x. And then it's better to write this as negative 2x all over x squared plus 4 to the second power. Try to always leave your final answers with positive exponents. That's usually how they'll be in like a multiple choice test, or like in your textbook. And that's usually how teachers and professors will want you to have your answer. So make that a habit. All right, next problem. Okay, so again, let's write this as, actually, let me just save a, well, let me save a line here. This is the same as 5x plus 1 to the negative 2 power. Then again, we don't have to worry about the quotient rule. We can just use the chain rule. And again, the outside function is a negative 2 power. So we're going to use the power rule. We'll get f prime of x, the derivative of the outside, which would be negative 2 times 5x plus 1. Take away 1 from that exponent, so negative 3, multiplied by the derivative of the inside, or the derivative of 5x plus 1, which is just 5. Again, leave your exponents as positive, so we're going to send this group to the denominator. And then so you'll have your final answer is negative 10 all over 5x plus 1 to the third power. All right, next problem. Okay, we got some trig here. Okay, so here we have the outside function as the cosine function. We're going to use chain rule again, but the outside function is just the cosine function, or you can think of it as 5 times the cosine function. So we're going to first take the derivative of the cosine function, which, as you should know, is the negative sine function. We leave the inside the same. And again, the 5 is just a coefficient. We can just always leave it there. So -5 times the sine of, again, leave this same, times -5 times the sine of 9x plus 1. And then multiply by the derivative of the inside, or the derivative of 9x plus 1, which is just 9. This is common for students to overthink, but it's really this simple. And then your final answer will just be -45 times the sine of 9x plus 1. Now we got another trig function, some good practice. So we just have a combo function. So let's go one piece at a time. So here we have the outside function as the cosine function. The inside function is 2x. And again, the outside function over here is now not just a cosine function, but the cosine squared function. And one way to think of this is actually what I would, because this used to always throw me off when I first was taking calculus. Let's rewrite this like this. Plus 2 times the cosine. This whole function is raised to the second power. So you can see the outside functions, the squared function. And then you have the inside function as, actually, let me write, I should see that in black. As the inside function is the cosine function. So again, this one can throw you off because you're gonna maybe think, oh, I gotta, my outside function is a cosine function, but the outside function is really the power function. That's all this is. This is the cosine of x times the cosine of x. So let's go from here. So here we go, y prime. The derivative of 1 is just 0, so it just doesn't matter. Minus the derivative of the cosine function, which is a negative sine function. So minus a negative sine of, and leave the 2x as is, multiplied by the derivative of 2x, which is just going to be 2 plus 2 times, and here we're going to use the power function. So using the power rule, we just multiply this by 2. So 2 times 2, leave the inside the same. We just drop the power and leave it as, you can leave it as a 1, or you don't have to write it there. And then we multiply this by the derivative of the cosine of x, which is the negative sine of x. And then from here, we can just simplify. So here you can see we're going to get the sine of, let's put this 2 in front. So 2 times the sine of 2x. 2 times the 2, 4, negative. So minus 4 times the cosine of x times the sine of x. That one's a tricky one. So this is a good one to practice with. All right, so there you go. I hope that helps. I'm going to keep these going, so make sure you look out for the next video because I'm going to have some more advanced examples for you guys to practice with. So look out for that one.